Why do imaginary numbers appear in quadratic equation roots? Imagine solving a puzzle where some pieces just don't fit on the board. That's kind of what happens with quadratic equations when their roots involve imaginary numbers. When you work through a quadratic equation, you use a formula called the quadratic formula. It involves a part called the discriminant, which is calculated as B2 for AC. This part tells us what kind of roots the equation has. If the discriminant is positive, you get two different real solutions. If it's 0, there's just one real solution, a repeated root. But if the discriminant is negative, things get interesting. Since the discriminant is negative, the square root of that negative number isn't a real number. In regular math, you can't find a real number that, when squared, gives a negative result. That's where imaginary numbers come in. Mathematicians define a special number called the imaginary unit, which is written as I. This I is defined as the square root of -1. So, when you encounter the square root of a negative number, you can rewrite it as a multiple of I. For example, if the discriminant is -4, the square root becomes plus sqrt -4, which is written as 2i. This allows us to find solutions to quadratic equations even when the roots aren't real numbers. The solutions will involve these imaginary units, and they always come in pairs called complex conjugates. For example, roots might look like 3 plus 2i and 3 2i. These roots are called complex because they have both a real part and an imaginary part. The reason imaginary numbers are useful is that they extend our number system beyond just the real numbers. This way, every quadratic equation has solutions, even if they don't cross the x-axis when you graph them. In fields like engineering and physics, imaginary numbers help describe waves, electrical circuits, and many other phenomena. They make solving equations more complete and consistent. So, to sum it up, imaginary numbers show up in quadratic roots because the square root of a negative number isn't defined within the real numbers. Introducing the imaginary unit, I makes it possible to express these roots clearly and accurately. This keeps our math consistent and allows us to solve all kinds of equations, no matter what the discriminant says.